Hey, what's going on, guys? KIM-1 here. So finally I made a computer of my dream, basically. So here we have the ESP32 that is running a KIM-1 emulator. So it makes it gives an output to the VGA, takes the input from the PS2 keyboard, and this is the power supply cable. And if we just turn this on and power the monitor, then we are in the KIM-1 ROM. So I've made some enhancements as opposed to the Arduino version that I've been making previously. So now, for instance, if I press F1, we have the shortcuts for keys and the memory map, and two most significant programs like supermon Plus 64 version 1.2 by Jim Butterfield, and the Tiny Basic, which is in the RAM, by the way, and can be overwritten by whatever program that starts at 2000s, which is quite useful, and Tiny Basic by Tom Pittman, are two major kind of parts of software available here. I also have some useful KIM ROM locations to like output the space to here to the serial terminal, whatever in the A register, getting character from TTY, like whatever, literally whatever I press keyboard we get here, and print the byte as the ASCII character. So we can also change the color schemes. Well, also I've added the F8 to clear the screen, but yeah, just probably forgot to add that to the README, so it should be here as well. We can change the colors. So for instance, green color, and everything goes green. Okay, like the yellow color, everything goes yellow, and the cyan, everything goes cyan. Let's drop back to the white again. Alright, so let's actually kickstart with the demonstration. So if we go to 9548 space and G, we found ourselves in a supermon, and here already, interestingly, that the program counter that was the little endian so far, now it should be displayed properly because I've changed the KIM ROM itself so that the program counter high and program counter low bits just swapped. So for instance, if I say go to 300s and enter, so there is nothing at 300s, just a break, just to give an idea. So the break there, so we have the zeros. But if I go back to 9548 and G, now the program counter has the correct endianness, so 302, just like what we have when we break. We had this 302, and now we have this 302 here as well as the rest of the registers are now being displayed properly. As for the features for the supermon, we still have the same like memory, for instance. So let's inspect the memory at the supermon itself. We can also disassemble. Let's disassemble the supermon itself just for clarity. We can fill the memory, transfer memory. I've been demonstrating that a whole lot of times, so no need to go for this one more time. So probably one last thing to demonstrate is assembling. So for instance, we have here we have zeros at the location 300s, and I want to write some program there. So for instance, I can say A, and starting with address 300s, then LDA, and let's load, I don't know, 12 to A register, for instance, and then automatically it auto-completes, calculates the next address, so I can continue from here. So let's say LDY, for instance, and 14, and for instance LDX and 15, like this. And if I disassemble 300s, then we get our program being assembled line by line. So if I now go there again, so G300s, go to 300s and executes, and 9548 going back to the monitor, and G. Now know that the value of the register, so we had 12 being set to the A register, it's now here, the Y register 14 is here, X register 15, it's right over in here, which is really nice. And for instance, if you want to move the memory, like if you want to move this piece of code, there is another nice little technique. So for instance, I can say T. Yeah, let's actually start with again, like disassemble 300s, and I just want to assemble one more line. So it doesn't make much sense, but anyway, so 306, 306. So I say, for instance, branch equals to 300s. Okay. And if I disassemble this again, 300s, now you see the offset that points exactly to this address. So now, what if we want to shift this this piece of code by 2 bytes? Let's say I want to add 2 more instructions. So in this case, I can simply say T, starting from 302, and up until 306, 7, I guess. Might be wrong, but hopefully. And then the storing address. So let's start this with 304. 304, enter, and disassemble 300s. Yeah, so it duplicates, but that's not a big deal, really. So for instance, add this 300s, 302, I can erase. Okay, disassemble 300s. Okay, something has gone a little bit wrong. No, it's okay. Actually, it's okay. So we have 3 bytes being freed up here. So, and for instance, here I can say like assemble 0302, and I don't know, let's say STA, and somewhere on the 0 page 10, for instance, just to make sure it's only 2 bytes. Okay, and again, disassemble 300s. Okay, disassemble 300s. Nope. Disassemble 300s. Yeah, so now we just added a new line here. So just move this, then added a new line, but here is a problem. So you see, like, now branch equals actually points to 302, because this is the relative offset, which jumps back the relative number of bytes. So in order to actually, we initially wanted this to be branch into 300s and not to 302. So it's not a big deal, really. Now we can actually change this by simply saying, so I can say assemble 0308, and I just say again, like, branch equals and to 300s, and disassemble again. And I see, like, it has changed. So we had F8, the relative offset, and now it's F6, and it points exactly to 300s, which is exactly the case. So that's the way how we can actually add new lines, which is absolutely essential for editing the text. This is almost it from my side, and one last thing I want to demonstrate is how to connect this KIM-1 emulator to somewhat a real computer via the serial port and lower the paper tape from there.